So welcome back. This is a continuations to the first video describing design pattern. So now when we are describing design pattern, pattern's name must be clearly mentioned. So now it conveys the essence of the pattern clearly expressed. Good name is vital because it becomes a part of design vocabulary. Then you will have an intent. That means the design pattern, what does the design pattern do? What is its rationale and intended? What particular design issues or problems does it address? Also, sometimes we can say the design patterns by putting the names, also we can find out its intention. So now, how a particular design pattern solves the problems which is occurring in the real environment, and how it is going to solve or resolve the problems. So now, intentions behind a design pattern is very important because a designer or a programmer has to find out the intentions of a design pattern so that he can or she can apply the design patterns in a particular environment. So now, thirdly, we can see the motivation. What motivation it takes or carries a design pattern. A scenario that illustrates a design problem and how the class and object structures in a pattern to solve the problems. So now this motivates the programmer, or it motivates the software engineer to use the design pattern. How can it structurize, or how it can have the illustrations process so that the problems which is occurred, so it can be resolved properly by using the classes and object structure. So now this particular motivations will help the designer or help the software architecture to resolve the real environment problems. So now this is a very important part of describing the design pattern, that is motivation. Next, to describe a design patterns, it must be the features of applicability. That means what are the situations in which the design patterns can be applied? What are the examples of poor design that patterns can address? How can recognize the situations? Now, this is about the applicability of design patterns. Which situations it can be applied? And we can find out the different low design patterns, or we can find out the different situations where the design pattern cannot be applied. So sometimes we may have a low cadre of design patterns which is not capable to address a situations. So now next part you will have a structure. So now the when we are describing design patterns, we have to see the structure of design patterns also. So now how can you structurize the design pattern? Graphical representations of the classes in the pattern using a notations based on the object modeling techniques, that is OMT techniques. So now we have to describe it, we have to structurize it through OMT process. Graphical representations, we have to show classes, objects and a relationship, and we have to completely we have to show the structure of the design pattern. The next elements, you will have a collaborations, how the participants collaborate to carry out their responsibility. So each and every objects, each and every classes, they are linked together, they are collaborating, all the elements, the objects and the classes, and they are solving the problems. So now in this particular elements you will find the collaboration, the relationship, the dependency, different components, different objects and classes we will see. So they are in a collaborative environment, so they have to satisfy, or they have to address the situations to resolve, and they have to collaboratively take the efforts and the responsibility to solve the problems. Then we'll have a next part, consequences. How does the pattern supports its objective? That means each and every design pattern has some objectives, and how they are supporting to that objectives, its consequences. What are the trade-offs and results of using design patterns? Now we have to reach to the result end. How can we get a result? and that consequences will find what aspects of the system structure does it let vary independently. Now sometimes we will have because of the design patterns we can make each and every system independently or it works. So if you will make a dependency on a different subsystem, that time the system complete system will be more complex and we cannot make any modifications further, or will have a difficulties to maintain further. So now these are the 3 points you will have in consequences that the how the design pattern described. So now next we'll have to describe the design pattern, that is implementation. So directly implementation part we can move, and what pitfalls, hints, the techniques should be ever about when it will be implemented in the design pattern. So we have to see. So now when it will be implemented and where it will be implemented, all kinds of implementation parts will be there according to a particular design pattern. Are there language specific issues? Now sometimes we will have a different design patterns, they may follow different kinds of languages. So that time implementation parts will take care, because this particular design pattern will take a different particular languages to implement. So implementation phase also takes care, or it describes the details how the design patterns can be implemented properly through if a particular language specifications is there. Then we'll have a later on we'll have a sample code. So now code fragments, that means we have to divide code fragments sub part of codes that illustrates how patterns can be implemented using different type of languages like object oriented languages like C++, Java. So these kind of languages we can use to implement, and we can prepare a fragment of codes or a set of codes so that the patterns can be implemented. So we have to directly jump to the coding part, and we have to use a particular languages or several languages to design the code fragments. For example, the patterns found in real systems. Examples of patterns found in a real example. For example, if we have a particular software which relates to a particular languages, we have to use that particular design pattern by using that particular languages. So now here we will see directly the sample code aspects. Now next part we will have a related patterns. Now what design patterns are closely related or differences? Substitutions of patterns that can be used for others. So now this is related to the patterns. Now sometimes you will have a number of patterns can be used for a particular scenario. So now you have to find out, you have to enlist the alternative or substitutions patterns, so that if we'll have some limitations or limited scope of a particular pattern, we can use other patterns which is a substitute to that patterns. So now in this particular elements or related patterns elements, so we can find out n number of or several numbers of substitutions patterns so that we can use. And the design patterns are closely related or differences. We'll find the design pattern which is related to the real scenario, or it is difference, how much difference it is there, you have to find out. That is about your related patterns. So now we have, as we know, gang of four, that is four authors, they have given their 23 design patterns as we follows in our syllabus. So now these patterns can be used by describing all these elements which we have already discussed. So now next we'll see the complete different types of, as I told, the design patterns according to the gang of four. So now there are three main categories of design pattern, that is creational, structural, and behavioral. So now these categories will have a 23 design patterns according to GOF. GOF means the gang of four authors, they have prescribed the 23 design pattern. These gang of fours, so first Eric Gamma, Richard Helm, then Raphael Johnsons and John Vlasides. So these four people, they have suggested 23 unique design patterns which can be universally accepted for any particular scenario or situation. Now first category is creational. What is creational? So the design pattern that deals with the creations of an object. So now when we are going to create an object or create an instance, that time we have to use creational design patterns. In creational design patterns, we have 5 design patterns, so we can use according to GOF. Similarly, structural design pattern, the design pattern which is a category deals with the classes structure such as inheritance and composition. Now we have to think about a design pattern's structure. So now we have to see the structure of a design pattern. That means a class structure, or how it inherits from the base class to derived class, and how we can compose different attributes to different classes or objects, or we can sometimes we can inherit the attributes from the different objects to other objects. We can add the different new attributes to an existing objects. So this type of structure, or to creating a structure of a class, creating an structure of a object or instance, so all related designs, it is categorized in structural design pattern. So structural design pattern, when you are discussing, that means you have to see the structure, the layout of the design pattern, you can say. Now next category is behavioral. That is behavioral design patterns. This type of design patterns provides the solutions for the better interaction, communications, links between objects, how to provide the loose coupling and flexibility to extend easily in future. Now here the point is, when we are taking different type of objects and we are establishing the relation, sometimes you will have a complex project, you will have a number of objects or instances or classes, so that you have to link it. That means you have to interact each and every module or each and every subsystem or each and every classes or objects. So that time the point comes interactions between the objects. Now when you are interacting, when you are making establishing the link or communications, that comes under behavioral. Our behavior, our or that's the object's behavior or classes behavior will find how it links to the other objects or classes or any other systems or subsystems. Now here the point comes, loose coupling means we have to create the links, we have to establish the communications, but we have to see that the dependency should be very less dependency or very minimum dependency must be there. Because if you will make a strong dependency on different objects, different classes, different subsystems, that becomes when we are going for maintenance, when we are going for coding aspects or implementation aspects, it will be more dependent on different modules, and which creates a different scenario difficulties to handle the systems. So now when you are establishing the behavior or establishing the links or establishing the interactions, so you have to see that each and every object should be in loose coupling concept. So loose coupling means there should be minimum dependency on that, or may not be dependency on that. So, so now second sections will or next we will discuss later on.